Everybody's heard the saying that failing to plan is planning to fail. But 8 out of 10 construction projects still finish late, and most of them probably had a 6,000 line P6 schedule. So the problem isn't that we don't appreciate that planning's important, or we don't actually know the technique of how to put a schedule together. The approach fundamentally comes down to we don't take the right approach to it. So in this video, I'm going to give you a complete overview of construction, planning, and scheduling, and how to schedule your projects so that they actually finish on time. So I actually want to kick this off with a personal example from a project I worked on that the problem and the mistake we made, I think, is the exact issue that most scheduling approaches don't address. I was working on the construction of a massive solar farm. Everything was going to schedule. We'd done the piling. We were proceeding with putting together all the racks that the solar panels sit on. As we came to the end of what is referred to as the mechanical installation, we were getting ready to start mounting the panels. Our clients then brought up whether we'd read the development approval and if we knew that we actually had to do the landscaping to shield the solar farm from the adjacent properties before we could actually start mounting panels. Unfortunately, we were not aware of this condition. The schedule we developed from the project never made a link between mounting the panels and the fact the landscaping was done because we didn't understand the actual methodology and the constraints we had to work under. So the entire job came to a stop as we frantically worked out how to urgently get a row of trees and install them. Construction scheduling consists of the tools and processes we use to make sure the project finishes on time. But more than that, it's actually expressing our construction methodology across time. Gantt charts are just an output of the process. Just quickly, if you do want to try out an easy project controls and scheduling software for the construction industry, then I'll put a link to Mastt in the video description you can check out. You can also check out our new AI agent builder, where we take all the complexity out of building AI agents that do genuinely useful work for the construction industry. Okay, so scheduling is methodology expressed through time. It's more than just putting information together in a Gantt chart. Putting together a schedule without understanding the methodology is like doing data analysis without data. But before we dive into the mechanics of what I think is the best way to prepare construction schedules, I actually want to unpack why scheduling matters so much. And to do this, I'm going to use a thinking strategy from the famous investor Charlie Munger called inversion. The idea is instead of asking why scheduling matters, you ask the question, what would happen if we didn't schedule on a project? So let's imagine we try to do a project without a program. What happens? Well, the first thing is we don't actually know when we're going to finish. We don't understand the sequence of the work, how long things are going to take, when we're going to achieve certain milestones, and importantly, when we're anticipating to finish the project. We can guess, but we have no science behind it. We can't tell the client when we're planning to finish, and then we can't forecast things like our overhead costs. It then becomes impossible to coordinate all the different trades and activities when they actually go. When do we tell the electricians they need to start on site? And how do we know if they'll have their equipment on time? How do we prevent two trades working in the same spot at the same time and running into coordination issues? And finally, how do we actually track progress? How do we know whether we're on track to meet our finish date, behind track? How do we know if we're doing more or less work than we should have? And when things change, how do we prove that there's been a variation and that the project's been delayed and we should be able to push back on our liquidated damages or claim an EOT? Fundamentally, a schedule helps us achieve almost every domain of project success. Obviously, it helps us achieve the project finish date, so we finish on time. It helps us reduce our overall project costs, both the direct costs, because we're not running into coordination issues and managing our resources effectively, but also our overhead costs because we can plan how long we're going to need site supervisors, managers, and other project overheads, and then we can reduce the duration of the program to save on those costs. It keeps our stakeholders happy and confident in what we're doing, and it supports our contract management. The schedule baseline is one of the most important contract documents because, again, any construction contract you have, time is such a critical component of that. So being able to prove that we've been delayed by the client and can't achieve our finish date is absolutely fundamental to managing contracts effectively. Now, the trap here is that we can have a Gantt chart that looks pretty and perfect exactly like this, but if it doesn't actually capture how we're going to do the project, how activities relate to each other, methodology, if the duration of tasks aren't correct, then It's not really going to support us in any way, shape, or form. The only way we get these benefits is by having a realistic, practical schedule that matches reality. So there's three phases to construction project scheduling. We have the development phase, which is where we build and create the original project schedule, which is mainly what we're going to be talking about in this video. We then have the implementation, where we've finished the schedule, the project starts, and we actually put the plan into action. Because again, a schedule doesn't have any value unless we actually implement it. Then finally, we have the monitor and control, where we track and compare what we said we were going to do versus what we were actually doing. So implementation, monitoring, control is more of a project controls concept. And if you are interested in that, then I'll put a link in the video description to a video we've done on construction project controls. But in this video, we're primarily going to be focused on creating a realistic and achievable schedule. And we're going to do this in 6 simple steps. Number 1, we're going to brainstorm the methodology. So we're going to we're going to engage with subject matter experts. We're going to map out how we're actually going to deliver the project. We're then going to turn this into a work breakdown structure, basically a list of all the activities we have to do in granular format. Then we're going to sequence these activities. We're going to estimate the duration of all of them. We're going to put this all together in a schedule model using a scheduling software. Then we're going to analyze and optimize the critical path. We're going to look at what opportunities we have to accelerate the program. Then we're going to get feedback and buy-in so the team understands the schedule and they commit to achieving. Okay, so as I said before, the foundation of any construction schedule is the methodology. How we actually compile all this information together is secondary, but we always need to start with the methodology. What is the actual process we're going to follow to deliver this project? Now, methodology can be a little bit of a broad, generic term, but what I actually mean by this is you should understand at a high level, even if you're not getting into the detail at this stage, the broad phases of the project. So if we're doing a commercial construction project, we have the earthworks, the foundations, the structure, the services, the fit out. If we're doing a road project, we have the clearing and grubbing, the bulk earthworks, the services and utilities, the final asphalting. I mean, I don't do a lot of road projects, so that was a little bit made up on the fly. But basically, it's just understanding broadly, conceptually, how the project's going to get done, what has to happen, how that is actually going to happen on site, what type of plants and equipment we're using, and who is doing what. If I use an example a little closer to home, something I'm more familiar with, and we talk about, say we've got an industrial facility and we need to put in a new switcher. I would want to understand everything about the task. Where are we buying it from? What design does the vendor need to start? Who's doing the detailed design? What equipment are we free issuing to the vendor? Who's doing the steel structure? What foundations need to be done before it has to happen? What size crane do we need to install it? Where is that crane going to set up? How's that crane going to get to site? How's that switch room going to get transported to site? Can it get delivered with the cabinets inside it, or do we have to install them on site? Basically, if you can't answer questions like this, if you don't actually understand how the work has to happen, then effectively you're trying to build a schedule without the information necessary. Now, super important to this, your role as the scheduler or the person creating the construction schedule isn't to know all of this stuff automatically. It's to find out the correct information. So a massive part of this, you don't have to do it all yourself. It's knowing who to actually ask. If your business is doing these types of projects, there should be people in the business who can answer all of these questions. So ideally, what you want to do is you want to have an expert per phase of the project, someone who understands the design, someone who understands the procurement, someone who understands the earthworks. Again, depends on the project you're doing. You ideally want to bring them on board early and involve them in the planning process. Now, this actually has a secondary benefit than obviously just making a better schedule. But if you remember from the steps of creating the schedule, the last step in this process was that we actually want to get buy-in from the people doing the work and building schedule. If we can bring them on in the brainstorming, the methodology phase, if we can bring them in very early, well, all we're doing is creating a schedule that is their plan. So they're going to be much more committed to delivering it. There's nothing worse than being given a plan that you've had no input in creating. But if you give people a plan that they have effectively created, then they're going to be very committed to seeing it happen. Okay, the next important concept to understand in this early stage methodology or planning process is this, what I like to call the opportunity to influence versus the cost of change. At the start of a project, we have imperfect information. We actually know the least about the project. We don't know how much it's going to rain. We don't know what the exact ground conditions are. We don't know what our exact productivity rates are. Basically, there's this massive corpus of things we don't know. So there's really two implications from this. Number one is we should try to buy information early. So what information can we get to make this stuff more, to reduce the amount of uncertainty in the project? The second implication this has is that we can't make a perfect schedule. If we're starting early on the project, and again, this depends a little bit on how much detail we have about the works, how much information we have, whether we have a detailed design, all these sorts of things. But understanding this concept of progressive elaboration, that at the start, there's only so much we know. So effectively, we don't want to be building a 10,000 line Gantt chart with incredibly intricate detail if we just don't have the information available now. So it's very important to be realistic about what we know and what we don't know, and plan based on what we know, but also consider the uncertainty within the plan. And then again, because it is progressive elaboration, scheduling is going to be an iterative process. We do our brainstorming, we come up with the additional methodology, we go build the schedule, we find out that the project's going to take too long, maybe we have to change the methodology. So while I'm going to lay this out as sequential steps to build a schedule, it's very important to understand that the methodology will probably be changing throughout the entire time we build this, that the durations of tasks might change as we change the methodology. All of this is interrelated. Okay, so we kick off with the methodology. The way we want to build the methodology is to brainstorm and engage what are referred to as subject matter experts. But basically, they're the people who've done these types of projects before, and they know exactly what is involved. Typically, you won't just have one. What you'll have is basically an expert per phase. So it depends a lot on the specific type of project you're doing. But say on a commercial building, you have design, procurement, the initial site preparation, earthworks, foundation structures, fit outs and services, and handover. The way I would expect, or the experts I would expect you need for this, you'd need like a design manager or someone like that to help with the design planning. You'd need a contracts admin or someone who's done a lot of procurement to help you map out how long to allow for procurement and what stage in the process you can kick off the procurement process. You need maybe some sort of logistics supervisor or overall site manager to help with the site preparation and the layout. Then you'd want to engage the relevant subcontractors to get their input into the earthworks, foundations, structures, and the services. Basically, all of these experts can help you get very detailed plans for each of the phases. Then, once you've identified your subject matter expert, the person who's going to give you all the information you need, you really want to structure the session so you get the most out of it. Do the legwork first. That would be the advice I would give. That before you actually go and ask them for input into the project, you first want to understand and basically compile all of the project documentations relevant to that scope. So if we're going to the earthworks contractor, we want their input into the schedule. We get the earthworks together, we get the earthworks drawings together, we do a quick quantity takeoff, we know the total volumes, we come up with an initial plan that we want them to critique. Nothing detailed, not a full Gantt chart, but just a rough outline of what you're thinking. You get them to critique it, and you've got all the quantities and information ready for them. And basically, you want to preempt all the questions you're going to need when you build the schedule. So the work breakdown structure, how would they break down the trades? How would they break everything up? The durations, how long would these different tasks take? The sequence, what order do they need to actually be performed in? What are the key risks? What are the key issues? What are the key unknowns? That's the stuff you want to already sort of have started to think about. Think about what questions you're going to ask them, get all the information together, then you can have a very productive, useful session with them. You could use something like an AI meeting minutes to actually record the conversation so you have all the notes. But the key here is you want to come at them with something, but then you're just really brainstorming and trying to get as much out of them as possible and try to preempt all the questions you're going to need for the work breakdown structure, the sequence, the durations. Okay, so once you've collated all this information together, you should have a very good understanding of what work needs to be done to deliver the project. So the first thing we're now going to create is our work breakdown structure. And basically, this is more or less the actual structure of our construction schedule. We might have, for a small, simple project like this example, we might only have 2 layers, but we might have 4, 5, 6 layers nested within. At the top level, we're going to have our phases, so things like design, procurement, earthworks, services. If it's a massive infrastructure project, you might break it down by zones. Again, there's lots of different ways to do this depending on the type of project. Then we just progressively break it down into more and more detail. The level of detail you want to get to is per activity, your lowest level of the project schedule, you should be able to come up with a single unit of measure to describe that task or some single duration. Each task should only have one resource or one person responsible to it. So for example, you wouldn't have the same task with two different subcontractors allocated. And then the third constraint is you want to break everything down enough to capture the linkages between. For example, in my for my example of putting up the switch room is I don't need a line item in my schedule for every column that goes up for the building foundation. I just need one for the structural steel because the structural steel has to be done before the building gets landed. So once we have our schedule structure, we then need to get to work sequencing all the tasks. The way I like to sequence the task, and again, a lot of this should have been done in that methodology workshop you had, but I use the strategy of pool planning. Pool planning, I find one of the most powerful concepts when it comes to scheduling. Basically, it's not starting at the front, you start at the back. So you start at the project completion and you go backwards through the schedule, always asking yourself the question, what has to be in place for this next activity to happen? So say my solar farm example, to energize the solar farm, we need the power turned on. To turn on the power, we need the cabling installed. To install the cabling, we need the trenching. So you're actually working backwards through the schedule because I find it a much more powerful question to ask is what has to happen for this task to take place? And then you work backwards through the scheduling, populating it. Now, there's a couple of different activity relationships that different activities can have. So the first is finish to start. 90% of activities in a construction project will have a finish to start relationship. And basically all this means is before activity B can start, activity A must finish. This is a finish to start relationship and will cover 90% of linkages. The next type of activity linkage is a start to start relationship. So these two activities start together at the same time, but they actually have a lag between them. So start to start is two activities starting at the same point of time. We can also have finish to finish, which is two activities finishing at the same time. Practically, I don't really use finish to finish that much. I use start to start and I use lags between them. But for example, you could have a concrete pour. Actually, no, that was going to be a bad example because that was also going to be a start to start relationship. But really, finish to start and start to start, I cover all the linkages I do. You also have finish to finish. Again, they finish at the same time. And then you have this other type of relationship, which I have never been able to think of a solid, good example on a construction project, but it's a start to finish relationship. Like I just can't even articulate what it means. Every time I think of think of an example that I think there's an easy way to express it as a finish to start or start to start. So that covers pretty much all the types of relationships I do. You can also have lags and leads between activities. So lag is a delay. So for example, the earthwork starting followed by the concrete slab, I actually have a lag between those because if this were a big project site, you could start the earthworks a couple of weeks after you could start the concrete works a couple of weeks after you started the earthworks because there'll be area for them to access. If that wasn't possible, you would need a finish to start relationship. And a lead is just a negative lag, but if you're using start to start relationships, you just put a lag between the two. Okay, the next concept to understand is mandatory versus discretionary dependencies. So you can have two types of activity relationships. You can have a mandatory relationship. You need to have done the concrete before you stand the structural steel. It's impossible to stand the structural steel without doing the concrete. That linkage is physically required in your schedule. The next type of activity relationship you can have is an optional activity relationships, or also referred to as a discretionary dependency. A discretionary dependency might be you have 2,000 meters of trenching, you could have one crew do it, or you could break it up into two sections and have two crews do it. You might choose to wait you might choose for all the fit out to be done before you start the electrical fit off because you don't want the two trades to clash. That would be an optional dependency. It's physically possible to start them at the same time, but you're choosing to put in an extra dependency between. So the way I would always recommend building your schedule is not to add your discretionary dependencies in on the first pass. Do your first pass with fixed reasonable resources, mandatory dependencies only. Then depending on what the critical path looks like, what the overall duration of the project sits like, go back and you can optimize things after. But if you start to include all your soft logic, all your discretionary dependencies in the schedule, it'll start to get quite messy. Yeah, one important point to make as well is you can have milestones within a schedule. So milestones are zero duration markers in a schedule. These would typically be things that you don't want to reflect the durations or sort of the methodology behind them. So say, for example, our client is free issuing us some equipment. We would put that as a milestone in our schedule. So a lot of client deliverables list as milestones, or if we have separable portions or big points in our contract. It's very powerful to actually show milestones on your client deliverables on the critical path. And I'll explain the critical path in a second. But basically, when we put in extension of time claims, when we make contractual claims, if we can show a client is late in meeting a milestone in the contract, it's very easy to claim for that. Okay, so once we've got our work breakdown structure, we've linked all the activities together, we need to calculate the duration of each of the tasks. So there's really two types of ways we calculate an activity duration. We have what is referred to as a production-driven task, which is going to be the duration of the task is going to be the quantity divided by the production rate. We have 2,000 meters of cable tray to install. We're installing it at 200 meters per day. 20 meters per day. We need 10 days to do it. We have to do 5,000 meters of trenching. We can do 50 meters per day. We'll need 100 working days to do the trenching. The important thing about duration-based tasks is the productivity rate has to be the production rate of the constraint in that process. So say, for example, we're assembling structural steel for our warehouse. There could be multiple different constraints to this process. It could be the rate we're delivering steel to site. So we might only be able to get 2 tons a day, in which case it's not the capacity of the crane. But we might have a huge stockpile on site. All the materials are there available. So we're more concerned about the rate at which the crane can put up the steel. So it's very important that when you're putting in the production rate for your activity, it's the production rate of the task that's slowing it down. But not all tasks you can express as a single quantity and production rate. Some tasks will be what are referred to as milestone-driven tasks. So say, for example, we're doing procurement on the project. We don't measure how fast we're going. We don't calculate how fast we're going to do procurement based on how many pages of a scope of works we could write, because it's just a meaningless metric. But those sorts of tasks are referred to as what I was referred to as milestone-driven tasks. And that is where we would want to get input from a subject matter expert. For example, if we know preparing a tender package like this typically takes a contracts admin 2 to 3 weeks, then that is the duration we would put in the contract. We don't actually do any sort of productivity. Okay, the duration, when we calculate it like this, only gives us the number of days or the actual time it takes to do the task. We need to convert that to a duration on our schedule. So this is where we talk about the schedule calendar. So the schedule calendar is effectively how many days you're working. If I look at this example of putting up structural steel, if we're doing 7 days a week, plus we're working night shifts, we're getting 14 shifts a week. So yes, we might only be doing 20 tons per shift, but if we're doing 14 shifts per week, then that task is going to be done much faster than if we're working 5 days per week. So most scheduling software will let you actually do this automatically. You put in the duration of the task, you put in the relationships, but then you can set the actual schedule calendar. So you can set within the schedule calendar, within the scheduling software, whether you're working 5 days a week or whether you're working 6 days a week, what breaks you're taking over Christmas. So basically we'll take the raw days you've calculated and convert these into actual start and finish dates. Effectively now, when we've worked out our work breakdown structure, we've got our series of tasks, we've estimated the duration for each of these tasks, we have our basic schedule model. What we need to do now is we need to analyze and optimize the schedule. The most important concept to understand with this is the critical path. The critical path is the series of activities that, if delayed, will delay project completion. So if we're looking at the construction of a commercial building, the earthworks will be on the critical path, because if we delay the earthworks, it'll delay us starting the foundations, which delays us putting up the building. But the landscaping around the building probably won't be on the critical path, because you can do the landscaping at the start of the job, or probably not at the start of the job because all the equipment will be in the way. But assuming at the end, after you get out of the ground and you're doing all the fit out and finishes, you could probably start the landscaping whatever, and it won't impact the completion of the project. So the question to ask is, if you can delay an activity and it doesn't impact the completion date of the project, then it's not on the critical path. And most scheduling softwares, you can just click a button and it will help you visualize the critical path. The critical path is so important to understand because that's the chain of activities that you need to be optimizing and thinking about. Because if any of the durations on those activities changes, it changes the completion date of the project. So that's where we want to be putting our time and attention. Now, what's also important to understand is the critical path is an estimate. We don't necessarily, because there's so many predictions, there's so many estimates that have gone into it. We've estimated the duration, we might not have our linkages correct. So it's also important to understand this concept of float. So float is how much an activity can be delayed before it falls on the critical path. So if I look at this very simple network schedule, you look at this activity here, this could be delayed 5 days before it impacts practical completion. This activity, same, could be delayed 5 days. This activity could be delayed 10 days before it impacts the next activity, which could then be delayed another 5 days. So basically, these activities aren't on the critical path, but they have some amount of float associated with them. Total float is how much you can delay an activity before it impacts the end date of the project. Free float is how much you can delay an activity before it impacts the next activity. So these two activities don't have any free float. This activity has free floats, but these activities have total float, meaning you can delay these activities and they don't fall in the critical path. So the reason I think float is important to understand is because activities that have small amounts of float practically are on the critical path. Because again, the critical path and all these scheduling softwares will tell you what precisely is on the critical path. But if something has 2 or 3 days of float on a year-long project, practically our estimate for the duration of the task is probably going to be plus or minus 5 days at a minimum. So practically it's on the critical path. And again, the critical path is where we put all of our time and attention because that is actually what changes the duration of the project. So say we go create our schedule model and we find we're running over the finish date in the contract. What can we actually do about it? So this is when we need to get into schedule compression exercise. Most tasks, say we have a normal start to finish relationship, you go task 1 and task 2. There's 2 things we can do to speed up an activity. We can fast track the activity, means we start task 2 before task 1 is fully complete. We start the electricians working in the building before the fit out's finished. This increases risk because there's a chance the electricians will catch up to the fit out crew and will be hit with a stand down cost. So that increases the risk. Crashing is where we don't actually change the activity relationship, but we just throw more resources at the problem, which typically increases costs because we might do overtime. We might work outside of normal hours. We typically won't be as productive because having 5 people try to do the same task isn't going to be as productive as 2 or 3 people working efficiently. So the reason this matters is because we should only be fast tracking and crashing. So we should only be increasing risk and cost for an activity if it is on the critical path. There is no point throwing hundreds of people to do our landscaping works if it isn't going to impact the finish date of the project. Now, the other constraints to think about when you're reviewing the scheduling is the resourcing. Now, if you're subcontracting out all the work, this won't be something you pay attention to as much. But if you're a self-performed business where you're engaging people directly to do the work, you have to pay attention to the resource limits. So you might have only a set number of people you can call on, which would be where you do resource leveling, where you smooth out the peaks, or you might do some overall resource smoothing, where you say, because we're going to have to hire people, we want 5 people working full-time for the duration of the project. So you would have to do some sort of resource smoothing. Okay, the final part of this entire process and why I think so many schedules go wrong is we then get buy into the schedule from the project team. Now, hopefully the same people who helped us build the schedule, our subject matter experts, have been involved in this entire process. We've been asking questions. So effectively, we have built the schedule they've asked us to create. But what we want to do now is we really want them to commit to the plan we've created, get them to review it. Maybe we present it to them. Maybe we turn it into staging diagrams or something that's a bit easier to understand. And we get the people who are actually going to be doing the work to commit to the schedule, because that is the only way the plan is ever going to match reality, is if the people doing the work understand what's actually involved in. And that effectively is the end-to-end process of developing construction schedules. But a schedule means nothing if we don't put the plan into action. That's why the next stage of construction scheduling is schedule implementation. But as I said earlier, I'm not going to cover it in this video. So if you do want a complete guide to construction project controls, then watch this video next.